Full wave rectifier, we are going to use two diodes, diode D1 and diode D2. You can see here, in case of a full wave rectifier, some modification, we have to use a center tap transformer, you can say CT, where we required this particular transformer for this full wave rectifier, diode D1, diode D2, and they are connected in a such a way that the center tap is connected to the resistor's other terminal. We can say it has to be connected to the ground in P spice, and this particular part of the this resistor RL, or we can say P part, it should be connected to the diode D1's cathode as well as diode D2's cathode, and anode should be connected to secondary. This is the secondary is S1 means at terminal A, and S2 means at terminal B. So what is in this rectifier socket? This actually center tap transformer, where you can see at A we are getting the alternating cycle or AC cycle like this, while in case of B you are getting a cycle like this. So there is almost 180-degree phase shift in the center tap transformer. So what it tells us that the positive cycles will be rectified by this D1. At that time this will be negative to this diode D2. So if it is negative to this diode D1, at that time it will be positive to the diode D2. So alternately, D1 for positive cycle, D2 for negative cycle, D1 for positive cycle, D2 for negative cycle, and so on. So this is the way the rectification can be done. So you can see the waveform in here. This is the input waveform, where you can see the alternating current, that is positive going, negative going, positive going, negative going, so on. While in case of this, you are going to see this is due to diode D1, this is due to diode D2, this is due to diode D1, this is due to diode D2, due to diode D1, this is due to diode D2, so on. In this way, alternatingly, one of the diode will be going to get conduct and others will be shut off at that time, and you are getting pulsating DC again, but at that time we are rectifying both signal, positive as well as negative. So when we use filter socket, so it is required very less time, so it will remain as it is. If we charge, it will remain as it is. It will charge, it will be remain as it is. That will get a smooth DC across the output of this rectifier after filtering. What will happen after filtering? We are getting a smooth DC. So let's check out in a PSpice software how the simulation takes. Just to be needed, we have to remove this capacitor actually. So we are going to see first without capacitor how this rectifier work. What we need L2, again also we need L3. I'm going to take L, I'm going to rotate it, I'm going to place over here. So I'm going to delete this particular component, this as well, just little zoom. So I have to take this to be in here, just dragging it down so that it will put, and the value of this is also to be 10 Henry. Now what we need a ground of this terminal like this, control W, this terminal actually to the resistance terminal, right? And then we need another diode D. Actually we have to take a diode with number. I'm going to take diode D2 as control W, secondary, or we can say B terminal. This should be connected to this diode D1 cathode. So look at here, diode D1's cathode and D2's cathode, they are connected directly and given to the resistance R2, and this particular R2's next terminal is connected to ground. It is also connected to center tap. Okay, fit to page. What is the remaining thing? We have to make them center tap transformer, so that's why I'm going to make here is to be as L3, save attribute. Okay, so this is to be done. In analysis, electrical rule check, I think there will be no error at all. File messages, 0 error, 0 warning. Then I'm going for the setup again to show you again transient. We are sticking with 0 to 100 milliseconds, close, and then we are going for the simulation. So what I've changed in the socket, like I have introduced diode D2. I have make this as to be center tap transformer, though they are looking like place here, but they are acting as a center tap transformer. uh, then we are getting like this. So you can see here, for positive half cycle, what is happening? The positive half cycle diode D1 is conducting, for negative half cycle diode D2 is conducting, and we are getting the pulses as it is, like a positive going pulses. So it is pulsating DC. So what we are going to do, we are going to introduce what we can say capacitor in here, so that it will be a filtered circuit. So I am going to introduce C in here. I'm going to rotate it here, place in here, with the value of 100, the value of 100 farad, not more, not less. We are going to connect that. So I've shown you, if we have higher capacitor value or lower capacitor value, there will be some sort of change in the readings. Okay, so analysis again, simulate. You can see here that for first cycle just neglected, this is the very first start. We are not going to see in real time at 10 millisecond. So start from this, like 40 millisecond or so on. What we are getting, because the capacitor is not charged actually at this point, so that's why it takes the voltage to charge it. And again at 40 millisecond onward, we are getting the constant DC voltages. So very less fluctuations will be there. So this is the way the full wave rectifier can be used with capacitor and without capacitor.